For decades, we've been staring at Mars and asking this one huge, profound question. Is there life out there? We've thrown everything we can at it. Rovers, orbiters, we've analyzed the soil, we've searched for water, but so far, nothing. It's been pretty quiet. But what if we've been looking in all the wrong places? What if the secret to life on Mars isn't about finding it, but about understanding how anything could possibly survive there? Well, the first clue might just come from a bizarre puzzle right here on Earth, involving our planet's most indestructible creature. So let's dive in. We're starting with an organism that is so tough, it seriously borders on science fiction. But when scientists decided to pit it against a simulated Mars, something totally unexpected happened. Okay, meet the tardigrade, also known as the water bear. This microscopic animal is a true superhero of survival. This little guy can survive the vacuum of space, it can withstand doses of radiation that would be instantly lethal for us, it can go without water for 30 years and then just kinda wake up. It's Earth's ultimate survivor, no question. So scientists put this champion to the test. They basically created a Mars in a jar, and they threw everything the red planet has at it. We're talking blistering UV radiation, a bone-chilling -80°C, and that thin, toxic atmosphere. And the tardigrade, it just kept on going. It survived. The tardigrade was proving to be pretty much unkillable. But then the researchers added one final ingredient to the mix, a chemical that they knew is incredibly common all across the Martian soil. And just like that, it was game over. Earth's toughest creature was killed, almost instantly. The experiment was done. So the big question was, what was this mystery killer? The culprit is a chemical called perchlorate. Now, it's a type of salt that, when it gets zapped by all that UV radiation constantly bombarding Mars, turns into something like a powerful bleach. It literally shreds the organic molecules that make up life as we know it. And here's the kicker. It is everywhere on Mars. So that sounds like a dead end, right? A planet totally covered in poison? But this is where the story gets really interesting. Because the very same chemical that kills life might also be the key to making it possible. This is what we call the perchlorate paradox. On the one hand, yeah, it's a sterilizing agent, but on the other hand, it's an absolutely incredible antifreeze. It's so good at its job that it can actually pull water vapor from the thin Martian air and create little pockets of liquid, salty brine, even when the temperature drops to a crazy -70°C. Now, this paradox creates a potential life cycle. Imagine this. You have microbes that are just dormant, kind of sleeping through the harsh Martian day with all that radiation. Then, at night, when the perchlorates work their magic and form that liquid brine, these microbes could wake up, have a drink, metabolize, and then go back to sleep before sunrise. It's a brutal existence for sure, but it is a potentially complete ecosystem. So what this all means is that if life exists on Mars, it is not just sitting on the surface waiting for one of our rovers to find it. No. It's hiding. The question is where? The search for these hiding spots really brings us to three main locations. We're going to start just beneath the surface, then we'll head over to the frozen poles, and finally, we'll explore the vast ancient cave systems on Mars. So our first stop is the most obvious one, just a few centimeters underground. You see, that thin layer of soil is actually enough to block the worst of the UV radiation and stabilize those wild temperature swings. The upcoming Rosalind Franklin rover is even designed to drill 2 meters down to see if it can reach any chemical traces of life. Next, let's go to the poles. The massive ice caps on Mars are a fantastic natural shield. Just a meter of ice gives you excellent protection from radiation. And deep below, geothermal heat coming from the planet's core could be melting the bottom of the ice, creating these huge, shielded pockets of liquid water that have been stable for ages. But perhaps the most protected shelters near the surface are ancient lava tubes. Billions of years ago, when Martian volcanoes were still active, these massive, kilometers-long caves were formed. Inside, life would be shielded from absolutely everything. The radiation, the perchlorates, the temperature swings. You'd have these vast, dark, and stable underground worlds. Now, all of those habitats are pretty close to the surface, but what if there's a whole other biosphere, a completely separate world of life that exists kilometers down, totally disconnected from everything happening up top? You see, recent studies are suggesting that the most promising habitat of all might not be near the surface, but deep inside the Martian crust itself. We're talking about vast aquifers of liquid water, maybe located 10 to 20 kilometers below the surface. At that depth, the natural heat from radioactive decay in the planet's core is more than enough to keep the water from freezing, creating a dark, warm, subterranean ocean. And life in a place like this would be truly alien. It wouldn't survive on sunlight, but on chemical energy from rocks. It would have been isolated for millions, maybe billions of years. Its life cycle would be so unimaginably slow, operating on a timescale we can barely even comprehend. And all of this brings us to the ultimate question. If we do find life on Mars, whether it's in a lava tube or a deep aquifer, what does that actually mean for us? Because that discovery would force us to ask an even bigger question. Did life on Mars start there all by itself, or is it somehow related to life on Earth? The answer would literally change everything we know about our place in the cosmos. There are two profound possibilities. In scenario A, life is a rare fluke. Maybe asteroid impacts flung microbes between Earth and Mars billions of years ago. That would mean we might actually be Martians, or they might be our distant cousins. But in scenario B, life is a second genesis. It arose on Mars all by itself. This would imply that life isn't a miracle, but a natural outcome of chemistry, and that the universe is probably teeming with it. Finding even one single Martian microbe that is not related to us would fundamentally prove that we are not alone in the universe. And it's no exaggeration to say it would be the single greatest discovery in all of human history. So the search continues. Not just across the surface, but deep within. Because all the evidence seems to suggest that if life is there, it's hidden from view. And that leaves us with one final thought. If life can hide just out of sight on our closest neighbor, what other secrets does the universe have waiting for us, just below the surface?